Hello wonderful person, this is Anton, and in today's video we're going to go on an exploration and we're going to visit a system by the name of Formalhaut. This system is actually quite well known to us, but we're going to talk about the science of this system and find out what we actually know about it in detail. Welcome to What the Math. Now, just like usual, I want to start right here on Earth, and I want to show you where the system of Formalhaut is located. And by the way, the pronunciation for the system has actually been debated for a really long time, mostly because it's actually from really ancient Spanish Arabic dialect, where it's either pronounced as FOMALHAUT or FOMALHAUT or in any other basically way, but the most important thing here is that it's actually based on Arabic, and it means in the mouth of the whale, or I guess fish. And that's because it's located in the constellation of Pisces, specifically in the southern part of Pisces, which I believe is referred to as Pisces Austrinus. And you're about to see it as soon as I type the name of this star in Space Engine right here. So Formalhaut is actually relatively close to us. It's only at a distance of about 25 light years, and you can actually see it. If you have, well, basically, if you live in an area that doesn't have too much light pollution, and if you have, I guess, binoculars or a small telescope, you can actually potentially even see the planet that we're about to talk about. So there it is. It's very easy to see. It's actually the third brightest star in our night sky. So it's a very interesting object, and what's even more interesting about it is that it turns out that it's actually a triple system. So let's actually go to it for a second. I want to show you where it's located and what it looks like. It does have two unusual neighbors. We didn't really know about them until very recently, but there's another star that orbits very close to it at a distance of just over 1 light year, and another star that's actually I believe a red dwarf that is a little bit farther, just under 3 light years, and these three stars are locked in a gravitational dance in a sense. They're basically kind of relatively close to each other, and we're about to see them here, at least one of them at least. I don't think I'll see the brown dwarf, but I'll definitely see the, oh, there it is. Yeah, that's the star I'm looking for right here. This is TW Pisces Austrini. An orange dwarf, a K4 type of a star, that actually is not very different from our own sun, maybe just a little bit less massive. And it does have quite a lot of planets here, but these are procedurally generated. But in Space Engine, interestingly, this star has a lot of really cool looking planets. We have a planet that kind of looks like Saturn, that has rings around it. We have another planet that looks kind of like a Neptune, that has even cooler rings about it. And a lot of other objects here, but that's really not why we're here. We are here to see the Formalhaut system, so let's go back to it. This is actually an A-type star, very, very bright, about double the mass of the Sun, and it's a relatively new star. It's actually relatively young. We think it's only about maybe 100 million years old, and this star is most likely going to live for a few billion years, but it's probably going to die before the Sun. And what is interesting about it is that we've discovered some unusual features around it that we don't see very often. One of these features is actually, well, you see it on the screen right now, it's a ring. We actually found several formations around the star that I guess you could call a disk. There is an inner disk, which unfortunately is not really seen in Space Engine, but is basically at a distance of about 0.08 or 0.11 astronomical units, so about 1/10 of a distance of Earth to the Sun. It's basically kind of right here. This disk is very, very easy to see with a telescope, and it's an inner really hot disk. In other words, this star actually kind of sort of has a ring around it. It also has an outer ring a little bit farther away at about 0.2 to about 1 astronomical unit, so basically where Earth would be located. And then there's another belt at about 10 astronomical units. And there's a dust disk, basically a disk that sort of contains a lot of dust particles at around 35 to 130 astronomical units. So there's actually layers of different disks here, and we can normally see these disks if we switch to infrared. Now, unfortunately, in this game, we don't really have infrared, but we can kind of imagine what it looks like by looking at the actual photos. And these infrared disks are quite visible, quite easy to see, and they emit quite a lot of infrared radiation that we were able to detect from Earth. But I guess, oh, by the way, there's actually more disks. Even further out, there's a main belt disk at around 150 astronomical units. There's another main belt at about 200 astronomical units. So there's quite a lot of layers here. But the most interesting part is, of course, this. This star has a planet that we discovered completely by accident back in 2008. I'm gonna go to it and take a look at it. This planet was not confirmed until 2012, and for the longest time we actually thought that maybe, just maybe, this was actually a constellation of debris, basically a bunch of rocks orbiting together. But then we discovered it by literally looking at it. This was the first planet we discovered completely by just looking at it with a telescope. And when we looked at it, we saw this. Okay, maybe not this, maybe something like this. Actually, maybe something like this. And a little bit darker, and something that really resembles this. This is what we saw. And this object actually orbits relatively far from the star. Its orbit is approximately 1700 years in terms of length, and it approaches the star at, I believe, as close as 30 astronomical units, and then moves away to around 300 astronomical units. And it has really, really high inclination. In other words, this planet that we're going to take a look at in a few seconds, it does go through some extreme seasons. When it's at a farther distance, it is ridiculously cold. When it's a little bit closer, it's still cold, but a little bit, actually, probably at least twice as warm. And we can actually see this in Space Engine by simulating these seasons. If we zoom out of here, and we're going to enable orbit here, and look at how magnificently elliptical it is. So right now we are actually in the summertime. So the temperature here is minus 160, sorry, degrees Celsius. And then if I accelerate time, in about just maybe over 1,000 years, it's going to come to the far side, and you'll see that the temperature actually dropped to like minus 250 maybe degrees Celsius. So it changes by about 100 degrees throughout its orbit. Now, this is probably not the only planet that this system has, but it's the only one that we could actually confirm directly. And interestingly, this is one of the few objects out there that actually has a real, actual name. So even though it's technically known as Formalhaut B, the official name as of, well, I guess a few years ago, is DAGON. Now, if you're an H.P. Lovecraft fan, you might know that Dagon refers to something in the story, but this is actually how the H.P. Lovecraft fan were able to get this name into the astronomical database. Dagon is also a name for a god. It's actually a deity from, I believe, Sumerian mythology that represents like a half fish, half person god. And for that reason, they were able to get this into the astronomical database, because we are only allowed to have names of deities when it comes to astronomy. Now, this object is obviously a gas giant. Now, we still don't really know how heavy, how massive it is, and we don't really know what size it is, but we know that it's most likely anywhere between the size of Neptune and about 3 times the mass of Jupiter. We also know that this was essentially the first extrasolar object detected by visible light, and the person who actually discovered it, Paul Callis, basically said that it's a profound and overwhelming experience to lay eyes on a planet never before seen. I nearly had a heart attack at the end of May when I confirmed that Formalhaut B orbits its parent star. In other words, when this scientist who discovered this planet actually confirmed that it actually exists and realized that this was the first ever exoplanet actually seen in a telescope, visually seen in a telescope, he was so impressed and so shocked that he almost had a heart attack. Now, to us today, it's not really a big deal because we've seen so many other planets, specifically even more interesting planets and even terrestrial planets. But back then, this was a big deal. And when I say back then, 2008. this was a big deal. Now, in terms of what else Formalhaut has, well, it is a very interesting star in a sense that it's very, very new. It's actually very young, and it allows us to study what young stars look like and what young stars actually go through while they evolve into much older systems. So it's very likely that we're going to discover a lot of really cool things here related to the various debris disks we discovered. But most importantly, we might actually discover how planets actually form in the long term. So right now, the planets here haven't really been solidified yet. They basically haven't really became permanent objects. In the next few million years, or possibly in the next few 100 million years, this system will finally kind of stabilize. But right now, it's still not very stable, and this is why we see so many rings around it. But what's interesting to us is that this actually represents the early solar system and allows us to study what our sun was like before as well. But I guess what's even more interesting is that we might be able to discover more planets here, and most importantly, we might even find terrestrial planets. And until then, we're definitely going to keep looking at this object because it's so close to us and because it's so bright. And so it's actually quite easy for us to see various types of objects orbiting around it. Anyway, that's kind of all I wanted to show you in this video, and that's all I wanted to kind of explain. Come back tomorrow to learn something else about space, sciences, or something you may have not known before, and subscribe if you still haven't. I'll see you guys tomorrow, space out, and as always, bye bye.